Okay. Okay, first of all, I want to thank Sorella and Crystal for making this possible. I'm really thankful to be here and to contribute to the community of Southwest Florida coders and the community in general. So thank you guys. Thank you for having me. And also being part of the 100th meetup is a great honor as well. So let's start. So what if you had a key that would not only unlock, understanding of React, the concepts, and all the built-in features, but also much greater understanding when you go out there on all the tutorials you can find online about React, and also be more productive when you're checking those out and not get confused about, oh, what happened to this step? I don't know what happened from this step to this one. So if you're interested in that sort of key, you're in the right place, because we're going to go in depth from React from the ground up. We're going to explain all the concepts, the principles, how you apply React in applications, and also have the ability to be more productive when you're creating your own apps. So who am I? I'm Percy. I'm a senior full stack engineer. I have 16 years of experience. I have built from APIs to large scale application, enterprise level applications, and have learned a lot along the way in the past years. And I also have experience with this, the stack you see on the slide here: React, JavaScript, TypeScript, Node, etc. that you can see there. And I have learned a lot, and I'm grateful to have been in so many learning experience that I had in the past. So one of the main questions many people ask, especially nowadays, is, should I learn React? There's so many JavaScript frameworks. There's so many competition coming. And as you can see on the Stack Overflow trends that I have here on the screen, you can see the React community going over all the rest, and still very active, even after all these years that React has. So it's a very active community. And not to mention the number of brands that are using it as part of their tech stack. So you can see many well-known brands there, and many more startups are using it, and obviously well-known brands as well. And when a library is being used this much, that it's a good opportunity for you. And not as well, there's a good amount of libraries just for React that you have. At the time that I prepared this slide, you have 246,205 packages related to React. So you have a great amount of libraries and possibilities that you can create so much without having to go from scratch everything. So you can focus on the features that you want to build and not having to build everything from scratch. So it's a big plus. So what is React? For those that don't know anything about it, it's a popular JavaScript library created by Facebook to build user interfaces. So it offers the ability to declaratively define user interfaces, components, well-defined with inputs, so you can customize them and make them render or show what you want. And also maximize reusability, where you can apply the same component multiple places and you don't have to repeat your code. And also deliver great user experience when you have a DOM, a virtual DOM on memory, that everything you do, every changes you do to the UI are posted there, and then they're posted back to the real DOM in one go. So many people ask, so how can I get started? So obviously, since we're dealing with presentational logic, you have to have basic programming knowledge, of course. You have to have basic JavaScript at the minimum because you're going to work with JavaScript code in the components. Also, you need TypeScript, which is adding types to JavaScript, so you can declare all the variables with types because types JavaScript doesn't have any types, and you have to have a certain control nowadays and apply that TypeScript. Learn basic HTML and CSS, and obviously have your computer to install some dependencies so you can get started building your React apps. I have here on this slide, for those interested, some resources that you can check out if you need to learn more about JavaScript, HTML, and TypeScript as well. These are 1-hour videos that you can check out, and you can snap a photo from that slide, and you can watch those, because it's very necessary to have that if you feel you don't have it, so you can get started easily. So every framework has a set structure. In React, you don't have anything written in stone that you have to follow, but it's always a good idea to have a structure on your project, so you know how you organize your files, where you're going to put all the resources and files that you're going to use on your app. So for example, you have a components folder that you can put all your components inside, meaning all the different pieces of the UI. You can put them in the components folder. The feature or pages, meaning you have a page where you have multiple components inside, and you can put all those components and arrange them in the way that creates a certain feature that you're building. And obviously you'll have reusable code, library code, and obviously TypeScript types, where you're gonna set up all your types on your application. This is an example of a project structure. This is not mandatory that you have to follow this structure, but this is just an example how you can follow the inside the source folder. I have a feature, and under the feature I have all the different pages like user, messages, payment, error, and underneath here you can see the components. So you have all the different components that you can reuse on your application, because we're building an application that you have all the different pieces, and then you put in composing together your app with all those pieces. So I hope you have your laptop ready. We're gonna have some hands-on coding here. We're gonna have the terminal commands that I'm gonna show in that color, black background. And if you haven't already, please connect to the Wi-Fi collaboratory guest and the password welcome. And you have to enter the voucher code that is right there if you haven't already. So you can have web access and you can follow along with us, okay? So first of all, you have to download and install Node. It's very easy. You just go to that URL there, nodejs.org, and just click on the downloads for your operating system. And after you're done installing it, you to make sure you install it correctly, you type on your terminal node.v, and you'll have the version number that you have installed on your computer. And for those that don't have any terminal app, I have here on the slide a recommended app, Commander, that you can download and use for your computer in case you don't have any good terminal apps. Okay, so what we're gonna do, you're gonna go to your home folder, go to your home folder. If you already downloaded Node, or if you haven't installed already, you don't have to execute this this command in here, but do go to your home folder and you're going to type npx create React app template TypeScript, and then the name of the project, my React project. That's going to be the folder name that's going to be created inside your home folder. So after that, you can cd into the project folder, so you can have access to the files. If you guys need a moment, or let me know. Okay. It's gonna take a moment to install the dependencies. First execute this npm install -g npx, and then you have to execute this command here, and then cd into the project. Okay. So what do we just do in this executing this command? So npx is a node package executor, which what it does is downloads and execute a node package immediately on your computer. And the different parameters are for specifying that we're going to use TypeScript for the format on the code, and the folder name, my React project. That's what this command does, so you know. And we're going to code our first component. If you have a VS Code or any IDE available on your computer, you can follow along. This is a summary of the commands on the Mac. So npx create React app, TypeScript, my project, cd, my React project, and you can go into the code editor inside that project folder. So so after you're there, you're gonna see the project folder, which you're gonna have these files on the root folder. You're gonna have the source folder. You're gonna have a configuration for TypeScript, package JSON, get ignore, and a source folder. So these are the main files that you have when you create a React project, when you start a new React project using create React app. And to follow along, all you have to do is clear there's some template code that you need to clear out, because it brings some template code inside the app.tsx, which is the main file inside the source folder, which is the one that we're gonna edit. So just clean up the code inside the class name app, everything in between, and then the logo, which is just showing a logo for React. That's all it's showing. It comes with that. So we're ready. We're going to create a simple calculator, which is going to do the basic operations that a simple calculator has. And we're going to have 3 form fields, 2 input fields, and a drop-down box, and a button. And as we build this app, we're going to explain all the principle and concepts of React, so you have a better understanding how React works and how we can build applications. So this is what we're going to cover while building this app. So what is TSX? JSX TSX is state, functional components, props. How do we compose new screens in React? How does React render components in the browser? What are React hooks? What are the most used hooks? And what are the and how to create your own hook as well. And how to maintain state between sibling components and parent-child components, so you can learn how to interact with the different setups that you can have when you're building a React project. So first of all, what is a JSX TSX you're gonna see code very similar to HTML inside a React component when it renders, when you're outputting the component code, the structure, but it's not HTML. Everything is translated, is transpiled into JavaScript code because when you transpile the code, everything is converted into what it looks like HTML code into JavaScript code, and it has some differences from real HTML, which is listed here. You can't have two parents in the root component. You can only have one, but if you have multiple ones, you have to use the fragment tag, which is this one. It looks like an empty HTML tag. We cannot use property names with reserved JavaScript keywords because obviously it will not work. And to use camel case everywhere for the properties. HTML is a bit forgiving. You can use any case and it works. But in this case, you have to use camel case all the time because it has to follow that structure. And for the CSS, you have to use object notation instead of strings like you used to use in HTML. So those are the main things to keep in mind. There are a few more differences, but these are the main ones that you should be aware of. Okay, this is the TSX that we're going to write in the main component. For those of you following up, you can scan that QR code, and there's all the code that you see on the screen is there on that QR code. Just copy it over. You can copy paste so you can go faster, and you don't have to write it down by yourself. And I'm going to explain that. If you guys need a moment, let me know to copy and paste that. You can post this online. Okay, yeah. Okay. Yeah, okay. Okay, a second. Okay, I posted in general. All right. So what you're seeing is very much, it looks like identical to HTML, but none of that code when it renders is real HTML. It just looks like HTML in the source code, but when you transpile that code, it will translate into JavaScript code. So after you type that over on your main TSX, the main command to run to start up the app to see what you have is npm start. You have to type that command in the root folder of your project so it works. And this will open your default browser, and a local version of the app will open. This is what the app looks like. It's simple, just two text boxes and a drop down along with a button. So you can have put whatever numbers you need and calculate the result. Right now, it doesn't do anything because we just are outputting the UI, but we don't have any code to run. So this is what we're going to do next. But before that, what is state? This is one of the main concepts of React, state, which is used to manage the component data. And a component state can change over time as the user interacts with the UI, meaning that you click a button, you hover over something and changes. and you put, obviously you have to assign functions to those event handlers so you can execute whatever code you need on those instances. So every time the state changes, it triggers a re-render on the component. And if that component has children, it will re-render those children as well. There are ways to optimize the app in case you don't need those child components to render, to show, to re-render as well. But I'm going to explain it a bit later in the talk. And we have event handlers where, like I was saying, you can have where the different state, you can trigger the changes on the event handlers. So typing, clicking, like I said, and very important, state is a sync. It's not like I can set a state in line 1 and line 2. I'm going to evaluate the new value that I have. No, it doesn't work that way. You have to use a callback instead inside the setter function. So it's one of the main things that confuse some people starting out. So here you can see it in action. You have the use state, which is being imported here. And that's the main hook that controls state. The state, you can understand state as the data inside the component that's going to render all the functionality or data that is showing. And here I'm setting up 3 pieces of state here for our calculator. And I have the submit for the form. This is for the button that when I click the button, it's going to trigger the unsubmit. And underneath here, I have the event handlers where every time I change one of the different text boxes in the calculator, it will trigger this on change on each of the 2 text boxes, and also on the drop-down box. It has 2 different event handlers that you can see on your right here, on change input, and is checking if I change the operand 1 or operand 2, and I'm setting the state. This is the setter function, and this is the data I'm passing to my use state hook. So this is my component data, so you guys can understand. And every time I'm changing this code is executing, and and the data is updating. My screen is updating at the same time. So this is what I just explained, the updates of changing the 3 pieces of state, and the re-renders that happen every time you change something in the application. So what are functional components? It's basically a JavaScript function that returns a React component, and we're already using one in the application inside the app function. It's a function that is a functional component because it's returning and meeting the conditions to be a functional component. So as I was saying at the beginning, we can break our different pieces of the UI in different components. We can manage state independently. We can re-render independently if we need to. Let's say I have a very expensive component that has a expensive calculation. I can render it independently than the rest of the components. So everything is modular. And I can also receive input from the component called props. This is what I pass to the component to behave in some way, so it can act like I want it to, or any configuration that I need to pass to it. So this is a simple functional component. Okay, yeah, sorry about that. Yeah. Yeah. Oh, yeah. Sorry. Everyone. Yeah. All right. So this is a simple functional component. As you can see, it can be more simpler. It's just showing the either an error or the result of the calculation of the simple calculator. For those of you that are following up, you can scan the QR code and follow along with the copy and pasting that code. And we have props here. Well, I'm going to explain that in the next slide. So we have here the props, which are the input that I can pass to the component. In this case, I have two props, one called result and another error. And this is the type I'm using in TypeScript, and I'm passing it here so that my so my component knows what types it should receive. And if I have an error, it will just display this error. Otherwise, it will show the result. So this is a very simple component. It's just showing the either an error or the result of the calculation. So the next thing is, how do we use a component? We already have a component created. We already have this functional component. How do we put it on the app to show it? Well, I have here, you can see the calculator result component, and I have the different props. As you can see, it's very similar. It looks like an HTML tag, but starting with an uppercase. And I'm passing the props. In this case, I'm passing the props, the result for 0, and the error, an empty string. And in the case you have declared that file, let's say you created this component in a separate file, you have to import it at the top of the file, and that component can be used on any other components output. So what are props? I already explained some of it. It all has to do with the types mostly, because it's highly recommended to use TypeScript. You can use plain JavaScript and not declare any type, but it's highly recommended that you use TypeScript. That way you can protect your types and the type of data that you can pass to your component, because we can make silly mistakes and pass data that will cause an error or bugs to our code. So it's best to use TypeScript. In case you're very new to TypeScript or you haven't heard about it, you can go to this URL here, TypeScriptlang.org, which you can check all the different types and how you can compose different types in TypeScript. It's huge. So do check that out. And the other, well, we were composing, we did a small, we had the app component, and then we created, we initialized the result component inside of it. So we have a parent-child component that we created, and that's how we created a new, let's say a new screen. Obviously, you can make more complex screen than that. Like we see here in the graph below, you can see a root component, and then you have three child components inside of it. And inside those child components, you have grandchild, great grandchild, etc. So you can see the hierarchy that you create when you build a React app. Everything is a hierarchy. And let's say I re-render this child 2, everything below will re-render, unless we have some mechanism to optimize our component not to render those as well. But it will trigger by default a re-render, meaning that everything will be re-executed again. So every time you change the state, it triggers a re-render on your application So every time you use that set function that we saw when I was talking about the use state hook, every time you use that setter function, it will re-render the application. So it's very important that you know that, because and what are the consequences if you have too many subcomponents inside there. Oh, and also when you want to transition a whole screen from one whole screen to another, there's a popular library called React Router that I'm not going to talk about here, but that maps URLs to different screens, so you can do a whole app with a very complex structure. So that's what we use when creating a very complex application with multiple screens. This is what I was speaking about before, how React renders in the browser. So we have here the different, the main component or the main app component, and I have the different subcomponents inside. When I generate the code, it gets transpiled into React Create element. This is the render phase that we have here. And everything React checks all the different changes you did to the state and calculates that in a virtual DOM in memory. And then when it finishes, it commits all those changes to the actual DOM. And that's how React knows where to how to render everything, and depending on all your changes that you did to your state or the user while interacting with the user interface. Okay, so now we're going to jump to React hooks, which is a very important aspect of React. And we've been using already hooks. In this case, they were built-in hooks, like use state is a built-in hook. But we're going to go deeper to creating our own hooks. And the reason for that is that you can reuse the logic, presentational logic in your components, so you don't have to rewrite code many times over, and you can save updating when you're changing your app. So what are some of the React hooks? We already saw use state. There's also use effect, use ref, use memo, and many more. I'm not going to go in depth into all the React hooks because it would take too long, but I'm going to go on the basics, the basic ones. The first one that we saw already is use state, which you can change the state or data inside your component. And it returns an array, the value of the current state, and a setter function. And you may be asking, but why does it have a const keyword in front of it? Is it a constant? Yes, it is a constant. Everything is immutable in React. Every change you make, you have to use it with the setter function. This is the setter function you see here in this example. So when I use state, I set, in this example, I'm setting the initial value to for my counter to be 0. And this is the setter function. When I click the button, you see the event handler here. It's going to execute this function, and it's going to set the count to whatever the count is, +1. And it will continue to update my button display, 1, 2, 3, 4, 5. And it will show the button updating the count as you click on it. So this is the reason that you see the constant keyword in front of it, because you have to update everything with the setter function. There's another one, use effect, that lets you synchronize a component with an external system. In recent years, the React team has changed the way this hook works because of optimization problems in many production level apps that use this hook too much. We have a setup parameter, which is a function that will execute, and the dependency parameter is here. We pass an array of the different pieces of data or variables that we're gonna monitor. It's gonna monitor any changes to those two variables. For example, I have server URL and room ID. It's gonna check if any of those changes, it's gonna execute this code here. And you can see there's a returning a function here. This is an arrow function for those that don't know ES6, but this is a function, and what it's doing when it's returning is saying, well, when you finish using this component and React disposes of that component, garbage collects this component, it will run this function. So anything inside here will run and disconnect. In this example, it will disconnect from the server. And in that way, you won't leave an open connection, for example, in this code. And this is what use effect is mostly used for. And you can check react.dev, the official documentation for React, which you can follow. And they have limited quite a bit the use of this hook. We have also useRef, which is very similar to useState, but in this case, it will not trigger a re-render on the app, or meaning it will not repaint the screen again, okay? In this example, it just has a parameter, the initial value, and you have to pass you can access the value with putting a .current, and that's where the value is. And then in this example, it's almost the same example as the previous one, but in this case, it's using useRef. Every time I click the button, it will call this event handler, and it will update my counter. It will increase it one by one. So this is a great use, like if you had like a local variable that you want to communicate in between different functions, event handlers, you can use ref. There are other uses as well, but I'm going to limit this for this talk on this one. And use memo is considered a bit advanced for some, but I think it's very necessary to use it. This is to cache the values or any function call that you want, because React is always re-rendering. Every time you make a change, every time the user interacts with some UI component, it's gonna update some piece of state, and maybe you don't want everything to repaint the screen again. Maybe you have an expensive function call somewhere and you don't want to execute everything. So you use this. In this example, this component is receiving, let's say, a big array of to-do items and some other parameters and the active tab. And let's say I just want this code to run when I change the tab or when I get new to-dos. So it will run this function, which is the first parameter here. And I have a dependency similar to the other hook in use effect. And it will execute only when any of those two variables change. So it will not overwhelm my code and running, re-rendering all that and running this function, because it can get slow when when you're building a very complex app. It can get really slow, fast. So here in this is outputting all the to-do items, and it has a key to-do ID. This is necessary for React to differentiate between items in an array on the screen. And this is if the to-do was completed or not, and if it does, it will be strike through the text. This is the tag for that, or the text, the plain text. So it's basically an optimization function that we can use for this for our components. So this is our hook that we, for those following along, you can scan that QR code and copy the code so you can and also there's a file that source hooks. If you can create on the inside your folder, create a new folder called hooks and use calc.ts because we're using TypeScript and copy paste the code here. What this code does is simple calculation for the calculator that we can reuse in any component. Let's say this logic, I don't have to, if I wanted to use this calculator logic in another component, now I don't have to copy paste this code in many places. I can just import the hook in the component that I'm going to use it, and I'm ready to go. I just use it. So this is how we can import the hook that we just created. Hooks use calc, for example, in this folder. And then you have, I'm calling my hook at the top of my component. All the hooks should be executed at the top of the component. You can't have any if statements in the middle because React has to know in the order that has to execute them. So you have to have everything without any if statements at the top because this is a simple function, okay? Here, I'm using the set operations and set operands here. I'm calling them, setting both. And by the way, I'm using useRef here, initializing them to 0, to a string of 0, both operands. And here I'm setting the 2. And those are some TypeScript types. I won't go in depth into TypeScript because it will be just a talk to explain all the different types in TypeScript. And I have my event handler here that we had already. And these are the main changes that are in this file. So the final app is this one. After I imported this hook and wire those functions, after I click calculate, you should see everything working as a normal calculator. So if I change the operation here, I can choose whatever I want and click calculate and it will work. If I divide by 0, it will give me an error. So you can see how the error works, but it has everything in there. In case you want to play with this example or you can code it, you can go to this repo where I have the code and you can download it and check it out. Everything is there. So any questions you guys might have, and also if you have any feedback, please, you can scan that QR code, what you like, and just 5 questions to answer quickly. But I'm going to take any questions you guys might have. If there was something you understood or maybe wanted to understand better, any questions, guys? Yeah.
Props were for passing state down, but how do you pass it adjacent or up?
Yeah, you can pass, usually you have a parent component where you have some state and then you pass them to a child component. And every time the parent changes that piece of state and you're passing it to a child component, it will re-render and do whatever you have configured on your child component. It will reconfigure that if your code depends on what values you're passing down on your component. No, it's one directional. It's one directional. What you can do is pass a function, a callback function, and that callback function can send data back up. Yeah. Yeah, any other questions, guys? Yep.
You mentioned one component taking more computational time than others, and that made me think of multi-threading. I wonder if you could touch on multi-threading. I've heard it's hard in React or challenging.
Well, I mean, it all depends on your browser because everything is executed on the browser. But React, what it does is it receives all the changes that were made to the component. Let's say I have a very complex component with many pieces of state changing. It consolidates all those changes and commits in a single step. So everything is rendered in one set. That's what it does to optimize. So I don't have to just change one state and then re-render another state, re-render. No, just one and re-renders everything. Any other question? Yeah.
This is more to really what you were saying with multi-threading. So other than like canary versions of Chrome and maybe some of the experimental versions of Mozilla, your JavaScript context is by default not going to have the ability to multi-thread anyway. You can incorporate things like service workers that will give you kind of a multi-threaded environment. But unless you start to loop in something like a canvas context or something where you can actually access a GPU, you're really not, in React, you're not going to build out a canvas in React just because at that point you're going to muddle your DOM by trying to maintain a virtual and a real.
Yeah, thank you for that. Any other question? Yep.
See if this works. If you had to oversimplify, what is the superpower or the one or two things that make React worth using over other ones? These are very popular, as you showed earlier. You know, to oversimplify it, why? What's the one or two thing? And then what's the one or two things that's really built for, like Facebook specifically? But you know, you should use React for this, and this is why it's better or different.
Yeah, React is mainly used for build user interfaces and the display logic that you want for your app. And you can call API calls, pull data from the server, everything. Like I said, the main features of React is how composable everything is. You can compose different components, simplify. You can use hooks to reuse logic into different components. You have the flexibility of breaking up the application into many different pieces. Usually when you have a team and you have a web designer, the web designer probably is going to have create different pieces of the UI. And usually that gives you a clue of all the different pieces you can break apart your app and optimize it. And also using the use memo, for example, if you have, I've seen screens that had even more than 50, 60 components at the same time. And you have to optimize that screen and not everything re-renders when you do a change on the state. So you can do those optimizations to make it faster, more responsive screens. But those are the main features, and also the big amount of the community out there is the biggest thing, because you have so much code already built for you that I mean, just having that huge community, it helps you a lot when you're building a production level app, because you have everything available, many great components already built, complex things already built, like a calendar, etc. You have everything built for you. You can even customize it. So, and it's growing, and the community is just growing over time. So for me, those are the biggest reasons to use React. And also, if you're looking for a job with startup or big tech, obviously you need React as well, because they all use it. So those are the main things that I would consider a good, why you should use it immediately, and why you should learn it. I mean, you have available other frameworks, but React is really still very active nowadays. No problem. Any other questions? Yep. Well, it's always a good idea, initially to go to react.dev, which is the official documentation. Why that? Why do I say that? Because many people will say, well, but the official documentation usually are very complex, but it's good to go there first because there are many tutorials out there, outdated. Maybe even if the date is this year, but the mindset is not updated with the latest. So you should first do a read of the React.dev. They have very good examples there. Follow that, and then you can go to different tutorials, different sites, and there are many courses in Udemy as well that you can follow. But do a read on the React.dev because there are many things, even the use effect hook that was previously used a lot everywhere, and now they're limiting to calling APIs, which is huge. I mean, those of you that have coded React before, you knew that I'm going to use effect here, use effect there, and now it's limiting that use, recommended by the React team. So, yep. Well, yes. I mean, for best practices, if you want your app to render to be optimally run, let's say you have a very complex app to run optimally, yes, you have to follow the best practices, because if you don't, you will have some bottleneck code in there, and it will be hard to debug and see what's the problem if you have too much logic or too many use effects. I was initially I used to use many of those, and now I'm trying to get away from using too many use effects. Yep. I would recommend there's I don't have the link right now, but I could share it later. There's a course in Udemy, which is really good. And there's another one. There's another free site that has another course, but I don't have the links here. But I can share those later, where you guys can check it out to use those resources. But it's a good read still to use the official documentation, and then you can filter the content that you read from that documentation, what is relevant, what is not relevant. Yeah, okay. Yeah.
A few years ago, I think this is when the use effect, they were trying to phase it back a bit. They really started on their website pushing for class components. However, in the past couple of years, I've seen that all their examples have taken class components completely out. Is React moving away from the class component structure?
Well, there are many companies that are still using it, and that's why the React team decided to keep it around, because there are many big enterprises that are still using class-based components still, and they're not planning to not use it. I don't know the reasons, but they just don't want to spend the money to rewrite all that code, and they're keeping it. But it seems that so far they're going to keep both functional components and class components. So it's unknown if they're going to phase it out or keep it as long as React lives.
Gotcha. Yeah, it just seems like lately they've been pushing the best practices to use a function component and use hooks instead of using a state-based class component.
Yeah.
Exactly. I think that's why they're. So I think we were talking about multi-threading. If let's say you wanted to build a canvas within a React component, you'd either have to wrap your reference within a use effect, which is going to then fire every single frame, which is causing a massive number of re-renders, Or you have to use a class component where you can use a did update hook where basically say, hey, don't re-render unless something changes. Recently with some changes, they have made it to where you can limit that using a functional component, but that's why I'm kind of worried. If I pull my class components out and put a function component, how is that going to impact the performance of my website?
Yeah, I mean, there are many things that usually when you're interacting with the browser features, you use ref basically because you're stepping away. Also, that's the second use of use ref, where you're stepping away of the React world into the browser world, and you're interacting with the actual component, the actual feature of the browser. And it's the best way to use it. I didn't cover that in this talk. I didn't want it to complicate it more, but it's why you use it. React offers some mechanism to interact with the browser, so you don't have to be dependent on the React lifecycle. Any other questions, guys? Yeah.
Sorry. Quick question. Is there any recommended libraries for state management? Or is it just keeping the current state? For example, like if you have a complex form that has about 15 drop downs and maybe 10 input fields, what's kind of the recommendation at that point? To get, for state, if it's like a global state, for that.
Yeah, good question. There have been many libraries as React has evolved, and many of those libraries have been obsolete as React evolved, and there are many new ones. One that I even started using recently. I can share it with you later. I don't have it here on the slide, but there are at least 5 or 6 good state libraries that you can use, and even Facebook created their own recoil, I think it is.
Oh.
The React team created one of their own.
And heard Redux too is popular.
Yeah, Redux. Yeah, it's being phased out. I mean, many people, that was the main de facto state library that was used for many years. I used it for many years, but now they're much simpler libraries that do the same thing, and it's much simpler.
Yeah, because I've been looking into like Redux, but but I've heard it's being like replaced or phased out, or like okay, so what's the new trend? Much like the class components and the functional, being what's functional components now. But there's still some debate about what to use. But okay, thank you.
Yeah. For forms, there's many other libraries for forms as well, but it all depends on your use case. If you're working with very complex forms, you have forms all over the place, then it's good to use a library for that. But in case of simple forms, you can use just React for that if you want. But it all depends on you, what you want to use, or your team as well. Any other questions? Yes.
Kind of a new kind of a question in your example here that if I want to do a front end development on a to-do list, but I want to persist that to-do list day after day, week after week, or whatever, what do I use that persist that to-do list so it's there when I come back Monday?
Well, I mean, to persist data, obviously you're working on the browser. You can refresh the page and everything will be gone because it's loaded into memory. You could either use an API, a database, where you can send that data and you can log in back as that same user and you can pull the data back again. Is the most recommended use. Or you can use it, you can save it as cookies, whatever feature on the browser, but it will not be a robust solution for that because you can clear the data, you can clear the browser data and it will be gone. So to persist data, you have to use, I would recommend using an API server where you send the data and then pull it back. Any other questions, guys? No? Okay. Thank you. Thank you so much. And there's also a coding challenge if you want, if you guys want to take it home. There's a QR code for it. Whatever level you feel you're at, coding at JavaScript, just pick whatever those are the requirements of the app. Is some color matching memory game. You can take it home, play with it. It's the best way to learn, and it will show you animated GIF of what it does, what it should do when you code this up, and you have all the resources there. The HTML code that you need and everything is on that QR code. So check it out. It's the best way to learn. I didn't learn this by just looking or reading. I learned by doing. So you guys can too. So this is something that you guys can take and play with it. So thank you. Thank you, guys.
Thank you, Percy. Okay, for the ones that are new with us, just so you know, we usually hang out here for a little bit. It's 8 o'clock right now, I think. Yeah. We're gonna stay here until 8:15. So like 10-15 minutes, and then we're gonna go and head out to downtown. We usually go to Downtown House of Pizza and we sit on the back on the patio, the little courtyard over there. So if you would like to join us, please do. You can leave your car here. There's a police station right there. There's security, so it's completely safe. We usually go walking. It's only like 4 blocks. But yeah, thank you everyone, and just feel free to hang out here for a little bit. For our time, we're just gonna close the shop now, but thank you for joining us. There's some thank yous for you. From Emily, going, yeah.
Great.
You can reply to me. Okay.